All right, everybody. I hope that you're able to hear me okay. Sorry about that. I was dragging the microphone a little bit closer. I'm sure you all did wonderfully on your test yesterday. If you were absent yesterday, the makeup for the summative will be on Monday at lunch. And that is put out as an announcement as well. So in class today, you should have picked up your new yellow packet from the front. And we are getting into our next topic. What we're starting with is a review of rational exponents. So take a few minutes and try to do this warm up on your own. For a certain light bulb, the intensity of the light measured in lux can be represented by the function I of d equals 100 d to the -2 power, where d is the distance measured in feet from the light bulb. What is the intensity of a light bulb if you are 5 feet away? And what is the intensity of the light bulb if you are 10 feet away? Now, if you have not attempted this on your own, go ahead and hit pause on this video and try it on your own. So hit pause. All right, so if you have attempted this on your own, we're going to go through this together. So the first thing that I want to look at or think about is our exponential rules. So I want to think about, well, what does x to the -2nd power mean? Whenever we have a negative exponent, we know we need to flip that underneath our fraction. So really, that's the same as saying 1 over x squared. So knowing that, we're going to move forward. So the intensity of the light bulb, if you are 5 feet away. So I'm looking at I of d equals 100 times 5 to the -2nd power. Simplifying, I have 100 times 1 over 5 to the 2nd power. 100 times 1 over 25. 100 divided by 25 leaves me with an answer of 4 lux. We want to include those units. And then looking at it again, trying again if you were 10 feet away. What we have is I sub 10, and my apologies, this should say 5 up here because we are subbing in 5. I sub 10, we have 100 times 10 to the -2. (100 times 1 over 10 squared). 100 times 1 over 100, and simplifying down. 100 over 100 leaves us with an answer of 1 lux. Leaves us with an answer of 1 lux. Now, last night, after you finished your test, you received a worksheet where we reminded ourselves of some of our exponential rules. So I want to go through some of those with us. I'm not going to worry about these. We're just going to review some rules. Going to switch it up a little bit. Just as a reminder, if I have the square root of x squared, those are our inverse functions, they undo each other. If I have x cubed raised to the 4th power, if I have a power being raised to another power, we multiply our exponents together. The same way when x, the square root of x is squared, if I have the cube root of x cubed, that's another inverse operation. So we get back to x again there as well. I know that the square root of x is the same as x to the 1/2. And similarly, the cube root of x is the same as x to the 1/3. Now, if we are very lost on these rules, there is a module in our classroom that walks you through the worksheet from yesterday. So re-going through a lot of these rules. And then the final one that I want to remind us of is if I have the cube root of x to the 4th, we would rewrite that as x to the 4/3. As x to the 4/3. So what we're doing today is we're going to rewrite our rational expressions in exponential form, our radical expressions. We're going to go the other way of take our exponential form into radical notation, and then we're going to get into some solving. All right, getting into some solving. So again, you can pause this video at any time. I'm going to go through the first two and then pause it, let yourself work some out on your own, and then catch back up with the video. So what we have here is we have the cube root of 15. Whatever number is in our radical, in the what I call the valley, becomes the base of the fraction. So if I rewrote this in exponential form, we would have 15 to the 1/3 power. If we come down here to number 4, what we have is the 8th root of 11 raised to the 5th. So the first thing I'm going to do is take care of my radical. I'm going to rewrite this as 11 to the 1/8 power, but I still have to raise that to the 5th. So my final answer here is 11 to the 5/8. Now, at this point, go ahead and pause the video and try 2, 3, 5, and 6 on your own. Okay, so now that you've tried those on your own, let's check our work. So I have the 4th root of 19. I can rewrite that as 19 to the 1/4. I have the 7th root of 5 raised to the 3rd. So I have 5 to the 3/7. I have the 7th root of 5 squared. So I'm going to rewrite that as 5 to the 2/7. And finally, I have 21 to the 7th and the 8th radical. So I have 21 to the 7/8. Whatever number is in the valley of our radical is going to become that base of that fraction. So now we want to rewrite our exponentials as radical notation. So I have 7 to the 1/4. I'm going to have my radical, and since the base of my fraction is a 4, that's the radical we're taking. And we have 7 to the 1st power, or just 7. Looking at number 10, again, I have a fraction as an exponent, so I'm going to create a radical. Radical notation, we have a 5 within our radical, and 8 to the 4th power. Go ahead and pause the video, try them on your own. All right. So finishing these out, I have the cube root of 13. I have the radical with a 3 in the valley and 9 to the 5th underneath my cube root. I have 5 to the third, and I'm taking the fourth root. And then I have 17 to the fifth, and I am taking the square root. All right, moving into our final part of our lesson today. We're going to start solving. We are not going to round. We're going to leave our answer in exact form. So we need to get x by itself. We know to get x by itself, typically we use our inverse operations to undo whatever is surrounding that x. So I know if I want to get rid of an exponent of 6, I need to take both sides to the 1/6 power. By doing that, I have 6 times 1/6, which leaves me with an exponent of 1, which is what we want, equals 64, the 6th root of 64. So we need to think about what number multiplied by itself 6 times is going to give me 64 to give us an answer of 2. All right, let's try number 14 together. Again, I have x to the 2/3 equals 81. So what I need to do is get our x by itself. So to neutralize my exponent of 2/3, I need to take my left side to the 3/2. Whatever you do to the left side of an equation, you have to do the right. So now my exponent simplified to 1. You can put an x to the first, but you don't have to. And I'm going to rewrite this as the square root of 81 raised to the 3rd power. Now, the reason that I broke it up like this is because I know the square root of 81. I know now that I have 81. Oh, I'm so sorry. I have 9. The square root of 81 is 9, raised to the 3rd power, to give me a final answer of 729. All right, we're going to try one more together, and then I want you to pause the video and try some on your own. So I have 5x cubed equals negative 1080. First thing I'm going to do is divide both sides by 5. To get negative 216. So I have x cubed equals negative 216. I'm not really sure what that is, so I'm going to just test some numbers out. I know if I'm taking the cube root, I need to simplify. So I'm going to start thinking of my numbers. If I'm thinking of 4s, I have 4, 16, 64. So I know that it's not going to be a 4. Let's try 6. So I have 6. 6 squared is 36, and 6 cubed is 216. So my final answer is x equals a negative 6. Now, go ahead and pause the video. I want you to try 16, 17, and 18 on your own. Okay, now we're here to check your answers. So I have x minus 3 to the 4th equals 16. First thing I have to get rid of is this 4th. So I know to get rid of an exponent of 4, I need to take my equation or my left side to the 1/4 power. And whenever we do the left, we've got to do the right. And that leaves me with x minus 3 equals the 4th root of 16. The 4th root of 16, well, I know 2, 4, 8, 16. So x minus 3 equals 2. And now we have an additional step to get x by itself. I'm going to add 3 to both sides to get a final answer of x equals 5. Now for number 17, this is not saying 17.5. It's saying 5 plus x to the 2/3 equals 105. I'm going to start this by subtracting 5 from both sides. X to the 2/3 equals 100. And to get rid of the exponent of 2/3, I need to take both sides to the 3 halves. Again, I'm going to rewrite this into what I know. I'm going to say, I know when I have a 2 on the bottom of my denominator, that's taking the square root. And then I have to cube it at the end. I know the square root of 100 is 10. And then cubing 10, I end up with an answer of 1,000. Just to really drill that in, our top number is going to be what we're taking the power of, and our denominator is what we're going to take the root of. If we know what the root is, we should get that done right away because it makes our number smaller and easier to be able to take that power. All right, last one that we're going to do. So I need to get x by itself. I'm going to start by subtracting 3. So I have 5 times the cube root of 4x equals -20. Dividing both sides by 5. Now to get rid of a cube root, I'm going to cube both sides. And finally, dividing by 4. Should be a -64, thank you. To get an answer of -16. Now, your homework for this evening is the following page. I want you to start with the odd problems. We're going to go over these in class on Monday, make sure we are all ready to go with solving these exponentials. I am very much looking forward to seeing you all on Monday. Like I said, I will have your test graded as soon as possible. If you have any questions, please feel free to email me. I will try to get back with you. At this point, if you still have class time left, feel free to start your homework and have a wonderful weekend.